Hey guys, this is Mitch with Finepoint CGI, and today we're gonna do a slight addendum to our inventory system. I have received a couple of bug reports that I wanted to make sure that we fixed, and the bugs are big enough for me to warrant some refactoring on our inventory system. And I also wanted to talk about how to add a weight system, and last but not least, I wanted to talk about how we can use submodules in our project to make our project a bit more flexible. That's what I have in store for you guys today. Let's go ahead and get started. So the first bug, if we hit play here and we take a look at this, we have a few bugs here. So first of all, when we add items and we come through and we add all of our items like so, we can add more than what we expect. So that's one bug that we're gonna have to look at. Another one that we have to look at is what happens when we try to trash an empty object. We can actually pick up empty objects, and that's a problem. And what happens when we actually trash them? And I can tell you because we're getting debugger errors right here where it's blowing up on us, but not actually blowing up Godot. So that's another one that we're gonna have to look at. We also have to look at when we're removing items, we do not fully check if we can afford an item. We actually just allow us to remove said item, and it's totally fine with that. So you can see that I can just remove, and that'll drop us into the negative in our inventory. So that's something else we'll have to look at. One more thing that we need to look at is I want to make it so that this inventory system is scalable for other people, so that way this can be used as a module. So we'll need to make sure that we modularize our code and make sure that our stuff is reusable across the board. So first we'll fix the adding an additional item when we can't add items. So if we take a look at our code here and we scroll up to the top, let's check out some of this code. So when we look at our input code here, we have a hover button here. When we hit play, we are able to pick up and move empty objects, and we kind of want to resolve that. So we can come in here and we can basically add a check. We can say, hey, are we over an object? And what I'll do is I'll come up here and I'm going to add in at export var can swap empty like that, and we're going to make that a type boolean. Okay, and then we'll come down here and we'll check to see if we can swap an empty. So if our hover button does not equal null, if we can swap empty, then we're going to do some code here, and then else we're going to do all of this code here. Then I'm going to take this bit here, I'm going to come down here, and I'm going to tab these guys in. So basically, if we can swap empty, then we can do all of this. Else, we need to basically check to see if it's a valid object. So we'll say if hovered button dot get quote current item, if hovered button dot current item does not equal null, then we know that we have an item that we can use, right? And then we can call all of this code right here, right? So we could just copy this and paste it down here. But we don't necessarily want to do that because that's duplicating our code, and we don't want to duplicate our code if we can avoid it. So instead, let's control X this. Let's come down to line 35 and let's just create a new function. Check for drag, and then let's just basically paste this guy in like so, and we'll need to tab these guys back like that, so that way it matches up with our code base. And then all we have to do is come in here and say, okay, check for drag and check for drag. There we go. And that should hopefully work for us. So now if we come into our inventory, we'll have an exported variable here, can swap empty. And if I hit play and I try to grab an empty, you'll notice that now it doesn't allow me to grab empties. If I added an item, I can still grab an item. I just can't swap it with an empty. If I added another item, I can swap these guys, but I just can't swap them with my empties. So that gives us a lot of flexibility, and it'll make our code a little bit more reusable in the future. And if we do the same thing with can't swap empty, you can see now we can grab our empties and move them around at will. All right, so now that we have that bug figured out, what's our next bug? Well, our next big bug is when we add our stuff. We can actually continue to add regardless of if we have enough spaces, and we can actually crash our game if we attempt to add more than what's available. So how can we fix that? Well, if we take a look, currently we're going off of our items.size, and while that generally will work, I think it would be best for us to move over to our grid container and actually go off of the children amount. We need to keep track of that. So if we come in here, we can basically just change this from items.size to grid container.getChildren, like that. And that'll allow us just to loop through and pull back our children. And now we can't have our items here either, because that's going to cause problems, right? It's going to break a bunch of stuff. So what we'll need to do is we'll need to keep track of if a grid cell has an item, because if it doesn't, then it doesn't really help us any, right? And then we can kind of retrofit our code. So we'll come in here and we'll say if current item does not equal null, then we can check if our item is equal to our item ID. And then if it is, then we can start taking a look at our code here. And we'll need to come down to here-ish and tab that guy in. And now we got to retrofit some of our code here. And this is where things are going to get kind of messy. So I apologize in advance. So first, items I.id, this doesn't work anymore because we're not pulling back our item index. Our item index is off in the ether, right? So we can't just pull back a grid container's index and then just say, yeah, it's good. It's going to completely break our game. So we need to convert all of our code over to be grid container based versus list based. And that'll provide a lot of flexibility for us. So when we do this, if items I.id, we'll just say i.currentItem.id and then currentItem.id. We'll basically just grab this guy, Control C, and then everywhere where it says items I, we can basically just replace it. So we can come in here, say items I, get rid of these guys like so. And I think I missed a space there. Here we go. And then we'll need to update our update button. We'll get down there in a second because there's a lot of changes that we're going to need to make down there anyway. So we'll come back to this in a second. We'll update this guy like so. And I think that will work. And then if we come down here to our current item quantity, we also need to convert it over because right now we're doing items appending and things like that. So we'll need to convert this over as well. So we'll say if current item quantity is greater than 0, if our current item is less than our stack size, for I in grid container dot get children like this. And then we'll basically do our check much like we did here, where we actually did our full check to see if it had an item and if it had the things that we needed it to have. We're basically going to do the same thing down here. So we'll basically just check if it has an item. If I dot current item is equal to null, then we can append that data. So we'll come in here, tab it over, and then if this runs, we don't want it to continue to run. So something that will break is since we're looping through our grid container objects and we're appending to that grid container, when we loop through and we add our item, if it's been added, then we don't want to add any additional items because it's going to completely break our project, right? It's going to just keep looping through and adding items until all of our grid containers are filled up. So we need to break. And what break does is it breaks out of this for each loop right here, and it breaks out of here and continues past that. So that's something to keep in mind. It's really useful when you're doing something like an inventory to just break out of your loop and then continue your code. You've done your thing, you know you're good. So once we have this, all we have to do is basically do the same thing for our else. So for I in grid container dot get underscore children, like so. Then we can again check if our current item, I really should just duplicate this. So if current item does not equal null, we can tap these guys in, and then we can take a look at some of this code. We can get a more in-depth look. So first things first, since we're doing a for each, much like the last time, when we do our add, we need to break. We need to pull out of that code. So we'll break. Second, we're going to want to adjust our update button. So our update button actually has some good stuff about it. So if we come down to our update button, which I believe is right down here, we can see int index right here. We need to update it to pass in an item because we can't just pass in an index, because if we say, hey, this is your index, since we're going off of grid container, not off of the item list, we need to add in our item so we know what item we have. So we'll say item, which we're going to make equal to null. We're going to default that. That's going to make things a lot easier in the future. And then we're basically going to readjust all of this and basically make it a bit less error prone. So first we'll check if our grid container dot get child at our index is equal to null. And if it is null, then we know that this isn't going to work. So we'll say print error child at index space plus str index plus quote is null. And this is actually code that I took from Robert here. So thank you for the code and thank you for the bug reports. If you guys actually run into issues with the game, please throw bug reports in. I'll be more than happy to take a look at them. So there are quite a few here that have been created by Robert or by myself, and it would be really useful for me to be able to debug my game and for you guys, because of course this is a framework, so you guys are welcome to use it. Now, I took the code specifically from him, so I just wanted to let you guys know. So that way I give credit where credit's due. Once we have this, we basically need to return. And that basically allows it to say, hey, if that index doesn't exist, just return. Don't worry about it. It's good. You're good to go. I'm also going to come in here and I'm going to just pass in my grid container and pass in my item like this. This is going to give us a lot more flexibility. It's going to make things a little bit simpler and easier to use for us. So we can basically use that to our advantage. And I'll get rid of these extra enters here. That's going to make things a little bit better. Also, since we're passing in an item and an index to our update item, that means we're going to have to go over to our update item and adjust that as well. But first, before we do that, let's go to our update button here and let's update our update button code so that way it kind of matches with our restructuring here. So first, we'll pass i.get underscore index, and we'll pass in our i.current item like that. And that'll pass in the item and the index. I.get index will get the index of our grid container, and I.current item passes in our grid container's current item. So that will allow us to basically do our error checking inside of our button. And I'm going to grab this bit of code here. I'm going to copy it and paste over top of this update button and paste over top of this update button. That way we actually have ourselves a system that makes sense. Now, I have a feeling that we're probably going to have quite a few bugs, but hopefully it's not going to be the end of the world. So we'll hit Control S. We'll head over to our inventory button object here. And let's take a look at that. Now, this is going to be pretty simple. Basically, when we do our update button, we pass in our item and we pass in our index. Okay, when we do this readjustment, we need to make some small adjustments here. First things first, we need to check if our item is null. We check if our current item is null, but we need to check if our item quantity is 0. Because if our quantity item is less than or equal to 0, then we know that it's null. That'll stop us from getting items that have a quantity of 0 and have an icon. That's something that I ran into when I was doing my testing and messing around. So we'll come in here and we'll just say if item.quantity is less than or equal to 0. And if that's the case, then we're basically just going to set these guys like so. And then we'll just drop an else and we will tab these guys in. And that'll basically do it for us. And that should pretty much do it for this button. And I think we should be good to be able to test. So if we hit back to our inventory, we hit play. Let's see what happens. So if we hit add, oh, nothing works. So that's a good sign. So let's take a look. We have no errors in our console, so that's always good. We hit a breakpoint on add and we hit play. Let's see what happens. So we hit add. What are we adding? We are adding an item. Being duplicated. We're looping through our stuff. We're checking if it's not null, which in this case it is. So none of this code is being ran. Our quantity, current item.quantity is 2, so it's over 1, so this should run. Our quantity is less than our stack size. If current item is null, items.append. So it looks like somewhere in here, I think there's a bug. Items.append current item, i.current item. So current item is null. So that's why. It's because I'm pulling back my current item. We should be passing in instead just our current item. There we go. And I think that will fix it. So if we hit refresh and we add an item, and I hit play, and there we go. Cool. So now if we just start adding items, what happens if we get to the end? Nothing. Good. So that's a good sign. If we remove items, everything gets removed. So that's not ideal. So we're going to have to look at that. But that's all right. If we drag out, we're good. If we drag around in here, we're good. If we trash it, we have some bugs. So that's not good. But I think we're okay with adding at this point. So let's see what this debug issue is. P index is out of bounds, size 19, items.remove at. So we're going to have to adjust that. So first, let's take a look at our remove code and let's see what's going on. So if we take a look at our remove code, currently it's running off of our items I. We're going to need to completely readjust all of this. So the first thing we have to check out is we need to look at our remove code here. You can see here we're checking for items.size, and much like before, we need to move over to our grid container. So grid container.getChildren like that. And that'll pull back our grid container children instead of our items. And then we can basically do the exact same thing. So we could just say i.currentItem.id is equal to currentItem.id. And I could basically just copy this guy, grab these guys, paste, and paste. And then to do our update, we can basically just pass this guy in like this, and that will handle that. And we'll need to .get index like that on both of these guys. And there we go. And we're going to need to check if our current item is not equal to null. So if i.currentItem does not equal null, then we can do all of this bit of code here like that. And I believe we can test this. So if we hit play, add in items, remove items, and we're still getting all of our items being removed. So that's not ideal. I wonder if it has to do with our reflow buttons. So let's take a look at that. Yeah, because we're doing I in capacity, so we're running through all 24 elements. So instead, let's do grid container dot get children, and let's check if I dot current item is equal to null, and if it is, then we can pass in I dot get index like that. Else, if we know that our current item is not null, then we know that we're good, right? We know that we have some form of item, but we also need to double check to make sure that we have quantity, because if we don't have any quantity, then we don't want to pass in a empty object to our button code. Even though we're checking for that in our code, I just want to make sure that it's good to go. So we'll just say I dot current item quantity is greater than 0, then we know that we're good. So we can just update our button. I dot get index, I dot current item. Like that. And then we'll just say else and update button I dot get index. And hopefully that'll fix our issue if we're lucky. So we'll run through that. Let's see what happens. So add item, remove, and now we're back to where we were. Cool. So now the question is, in our code, we're running through and we have no way of knowing if we can remove an item, right? So right now it is just going, yep, we're just going to remove these items. We're just going to destroy them and call it a day. Even if the item doesn't exist, we're effectively paying for an item that doesn't exist. So if we were to have a weight system, or if we were to have some kind of buying and selling system, this wouldn't work, because we basically could remove an item forever because we have no way of knowing if it was successful. So let's make sure that we can check for that. So we'll put a little pointer in here and say Boolean, so we know that it's going to return true or false. And at the bottom of our reflow buttons, let's fire off a return true, and let's come in here and make sure that we can afford this, okay? Because right now we're just going to return true, but obviously we need to check to see if we can actually afford this item, if that makes sense. So if we come down here, we can just say func can afford, and we'll pass in an item. If you've seen our C# side, we actually already did this, but var count, and we'll make that a type int, like so. And then we're going to loop through all of our children. So for I in grid container dot get children, like that. And I know you're thinking, why not just index this? Instead of grabbing our children amount every single time, why not just create a list of our grid container children? And we could, but then if our stuff should change, we need to make sure we update that. So it's up to you guys. To me, it doesn't really matter too much, but it is something to keep in mind. If I dot current item does not equal null, then we know that we have an item. And if I dot current item dot ID needs to equal our item dot ID, so that way we know that it's the same item, and then we can actually increment our count. So we'll increment that. So plus equals our item dot quantity, like that, and then we can just return our count is greater than our item dot quantity. And to do some type safety, we'll just put a little pointer here, Boolean. Now, what does this mean? Okay, well, first things first, var count int, that's basically setting up a count, because we need to know if our count is higher than our item quantity. We can't just check our individual cells against our item quantity, because if we did that, then we wouldn't have a full picture of all the items, because what happens if we have two stacks? So instead, what we're going to do is we're going to loop through all of our stacks. We're going to count up how many we have of each of that one item, and then we'll return if it is greater than item.quantity. Now, this is equivalent to if this return true, else return false. Like that. This and this is absolutely equivalent. So you don't need to do this. You can just do this, and Godot will understand what you're trying to do. So that's a way to save yourself a little bit of code. And I'm going to reflow this just a tiny bit. There we go. Just because I don't like having all that extra space. Now, we do need to check if we can afford an item when we remove it. So let's just say if can afford, and we'll pass in our item for reference. And if we can afford it, then we know that we can remove it. So we'll just remove it. Else return false. Now, you could do else return false, or you can just do return false, like so. And that's technically valid as well. Else return false basically just says if this else, just return false. But if this is not true, then it's automatically going to come down here anyway. So we don't need that else if we don't want it. And it's up to you if you want it. So now if we're lucky, we should be good to go. And the best way to illustrate this feature here is by printing out our remove. So if we go print remove, like so, this will return a true or false. So if we hit play, you'll see if I add an item and then I hit remove, you'll see true. If I hit remove again, you will see false. So now we cannot remove anything that doesn't exist. So if I have item 2 and I hit remove, you'll see I still get a false. If I add an item and I remove, I get back a true. And same thing, if I remove this guy, it's going to give me a true as well. Of course, I don't have it printing, so of course it's not going to show, but it will work. Now, we should do the exact same thing for our add. We want to make sure that we can successfully add stuff as well, because if you're purchasing an item or something, we want to give them the ability to say, yes, you can afford this, or no, you can't afford this. So if we head up to our add section here, we can basically come in and do the same thing. So we'll come up here, we'll put a pointer like so, and we'll make that a type Boolean. And then we need to make sure we return our code to some form of path. Now, if we're appending, we don't really need to worry about appending. It doesn't really matter. But if we are checking our if right here, if we are adding, we do need to make sure that we return either false or true. So you can see here, we have this if statement here. We have else. So if this is true, then we can return true. Else we can return false. And hopefully that will work for us. Let me see. Now, the best way to test our add and remove system is by adding in a wait system. Adding a wait system was a highly requested feature for this inventory system. So let's add that in. So the first thing that we got to do is we have to export out a few variables. So the first one that we have to export out is how much weight can we actually have. So we'll just export out a max weight value, and we will set that equal to something like, we'll set that equal to something like 0 by default. And we need to have a variable for our current weight. And we'll set that to 0 as well. Now, what we can do is we can check our max weight. And that's how we can determine if we're going to use a max weight system or not. So basically, if we set this to 0, then we know that we're not going to use the max weight system. If it's anything above 0, then we know that we are going to use it. So that'll give us the ability to have a flexible inventory system. Like I said, all of my code is open source, so you guys can just use this code for any of your future projects. So if you scroll down here to set up a weight system, first we have to check for that weight. And the easiest way to do that is right down here. We can basically just say if max weight is greater than 0, then we know that we can actually check for our weight. So we'll say if current weight is greater than or equal to our max weight, then we know that we have too much weight for our character to hold on to, and we don't want to add an item to our inventory. And we'll just return. So basically, if we're over our max weight, then we can just return and we're good to go. Now, what we also need to do is we need to actually assign a weight to our items. So our items don't technically have a weight attached to them yet. So we need to actually do that. So we'll just export var weight, and we'll put a float in there. And that's going to be the weight for each individual item, not for the total quantity of items, if that makes sense. Now, if we save this and we come down into our test item, we double click on it, you'll see now we have a weight value. So now I could set it to something like 5, let's say. And I know 5 is probably really high because that means we're going to be dropping in 20, weight value. So like 20 pounds worth of weight onto our stuff every time we add something to our stack. But this is for testing purposes, so it should work pretty well. So if we go to our inventory, we want to basically add to our weight amount every time we add an item. So what we can do is down at the bottom, right before we finish our function call here, we basically can just reflow our buttons, much like we did down here in our remove. Right at the end, we have a reflow buttons. I'm thinking that we could probably get away with doing this, but with our weight. So I'm just going to come in here and say reflow buttons like that. And then we'll come into our reflow buttons and we'll actually update the weight of our inventory when we do our reflow. So if we come in here, we can basically say for I in grid containers get children, we can say current weight plus equals our I dot current item dot weight multiplied by our I dot current item dot quantity. And when we do our reflow, we're going to want to set our current weight equal to 0. So current weight is equal to 0. And now every time we add or remove an item, our entire inventory gets updated and our weight gets updated. Now you could technically be a bit more efficient by going in and not reflowing all of your buttons. You wouldn't have to loop through all of your grid container, and that would probably simplify some things. Then you may find yourself getting in a situation where something might not work just right. And I don't want to take that chance, so I think this would be the easiest way. So now if we just print what our current weight is on our add, so let's come up to our add and just print our current weight. So I will do it right here, I guess. So print current weight, and I'll also print my max weight as well. And I'm going to look at my inventory real quick. My max weight is 0. So right now, this should not care about how much weight we have. So if we come in here and we add an item, you'll see right now we have could not get index weight on base nil. So that leads me to believe that my I.current item does not have a weight value. Did I spell weight wrong? W-E-I-G-H-T. That looks correct to me. I.current item dot weight valid index on base nil. So that's because our current item is null. So this would not work unless we get rid of this and we add it into right here, because this is the only time when something's going to have weight. So that's my fault. So this should not be here. It should be right here. And then if we refresh, let's try this again. So we'll hit add, and you'll see that our weight is increasing, but we don't actually check to see if we're over our max weight. So we can just keep adding items. And when we remove items, it's not coming up with anything, but that's probably because I'm not printing it. So if I come back here and I re-add, that puts us to 80, 140. So if I get rid of all but 2, and then I add, we should be at something like 10. Yeah, I think that's correct. These are 5, that's 25. So no, that's not correct. So we're going to have to look at that real quick. But let's check our max weight. So if we come into our inventory and we set our max weight to something like 20 and we attempt to play and we hit add, we are at 10, which we should be at 20. And we're able to add past our weight. So let's take a look as to why. So we'll put a breakpoint here. We'll hit play, add. Max weight is greater than 0, so that means this code will run. If current weight is greater than or equal to max weight, that's fine. So we'll let that go through. We'll put a breakpoint right here. Max weight is 20, current weight is 10. Go through, play. Current weight is 20, max weight is 20. So now it should return. And that works. Okay, good. So you can see we can no longer add any more because our weight is over our value. And if we remove an item, you'll see we're at 2, 0, and we can't remove any more from there as well. And if we add, we can only add the 2, we can only remove, and that works. Now we'll just set up our weight system so that we actually can see what our weight looks like. So we'll go to our inventory here in 2D. And we'll come down here, and where our button is, we're basically just going to right click, add in a child node, and add in a label like so. We'll just drag this guy down here. We'll make it about this big. We'll type weight, colon, and then we will duplicate this, pull this over, and do something like 10/10. And what I'll do is I'll come into my inventory, and when we update our weight right down here in our reflow, we actually change our weight right here. So right at the end, what I'll do is I'll just say $, and let's name this as weight value like that, and weight label like that. And then I'll just do $, weight value dot text is equal to str weight current weight plus quote slash plus str max weight like that, and that should do it. So now if we hit play, you'll see that we have weight 10 of 10, which it should be 0 of 20 technically, but if we add, you'll see it says 10 of 20. We remove 0 of 20, 20 of 20, and there we go. Simple enough. And we can no longer add any more. We can't subtract anymore. And that's basically how we can add weight to our system. Now, at this point, we're basically done. I mean, we can come in here and just set up our weight value. So $ weight value dot text is equal to str current weight plus slash like so plus str max weight like that. That way that just gets set up immediately on startup. So you can see weight 0 of 20. And there we go. And also we can't add a second item or remove a second item because we're over our weight value. So that's basically the beauty of having a weight system, is that it makes it so that you can't add more than your weight unless you want that feature. And if you do, then we can actually code for that. So how we can add weight more than what our player is allowed is by coming into our add right here, and we can basically say if max weight is greater than 0, if current weight is greater than max weight, return, right? Well, what we also can do is we can say and allow over weight, not allow over weight. Now I know we don't have allow over weight, so we'll scroll up here and we'll just add that in. So at export var allow over weight, and we'll make that a type boolean. And we also can add in var is over weight, and we'll make that a type boolean. And now we can just come down here in our reflow button and we can just check if allow over weight, then we can do our check. So if weight, current weight is greater than max weight, then is over weight is equal to true. Else it is false. Just like that. And we can actually shorthand this by saying is over weight is equal to current weight is greater than max weight. And that will shorthand that. That makes it a little bit easier for us. And that basically allows us to check if we're overweight. We also can check if is overweight than $, weight value dot add color theme override font color, comma color, and we can make it whatever color we want. So it's going to be an RGB, so RGB. And then we can say if he's overweight, do that. Else we can basically just do the exact same thing, but instead set it to 1, 1, and 1. And what this is going to do is it's going to set our value to red. So if we come to our inventory, we say we allow for overweight, our max weight is 20. If we hit play, hopefully this will work. So add, you can see now it's red, 40 over 20. He's overweight, that's going to be a problem. And now in the future, when we want to integrate this into our game, we can check if we're overweight, and if we're overweight, we can apply a movement debuff. And that's basically how we can create our stuff to be flexible. I have two more things that I wanted to do before we finish this up. And the first one is underneath our scripts, we have an item.gd. Let's come in here and type class underscore name item. And that should allow us to see it. If we come down here and we right click and add in a new resource, and we could just type in item and it will now come up into our resources. And that will be really useful for us in the future. Thank you for all the people that have yelled at me multiple times on how this works, because I just couldn't get it to work for whatever reason. So now we can just add items this way, and it's going to be a lot easier than adding in a resource and just passing it in. Now, the cool part about doing a class name item, that means that we now have type safety, or we have the ability to have type safety. So if you come over to our inventory button and we go to our current item, we can just hit :item, and now it recognizes that as an item. So we could actually come in here and say as type item, like that, and it should take it. Same thing with this as a type int. So that's kind of nice, because now we can come in here and just go item dot, and it will have all of our item parameters right here. We can actually see them. So that's really nice. So we can run through and quickly set up our items as an actual typed object. So we can come down here and say, instead of as a type resource, as a type item, and we can come down into our remove and do a type item. We can come down into our can afford item as a type item, and we can do the same thing with our function update. It is a type item, and it is equal to null. And our current item, which would be a type item as well. And that'll just help with getting our code to be more easier to understand and generally better to use. And last but not least, let's talk about making sure that our code is modular. So one of the big things that we do in coding is making sure that our code is modular and reusable. Why build another inventory system if one already exists? Unless you have a very specific use case, generally speaking, you can always just reuse those tools. So, in the spirit of that, let's talk about submodules and let's talk about abstracting our code into separate repos and combining them into a project. So, if we come over here on the file system right here, and we right click our RES and we added a new folder, and let's just type add-ons like that. And let's right click, added a new folder, and let's add in FPCGI. In my case, I'm going to use FPCGI. Of course, you guys can use whatever you would like. And then let's right click this one more time and do a new folder, and let's type inventory. And we can basically have everything underneath our inventory. Now, how I like to set up my add-on scripts is I like to right click and add in a new folder, and I like to have a scenes folder, and I like to have a scripts folder. And then from here, we can basically just grab all of the stuff that pertains to our inventory and just have it out here in its own segment of code. So if we grab our item, we grab our inventory.gd, our inventory button.gd, and we just drag that up into our scripts. And same thing with our scenes. So inventory button, and I think that's it. So we'll grab both of these guys and drag them up, and we'll hit OK, and it should be fine. Once we close everything, we reopen up our inventory. If we hit play, you'll notice that Godot will get very mad at you. And that's because we've moved some stuff. So you can see that it attempted to load the wrong location. So we'll need to update that. So what we're loading right here is we're loading a packed scene for our populate button, for our inventory button. So if we just click on that, Control A, copy, and then paste that guy in, that will update that. So we'll refresh. And there we go. So now we can add our items like normal. We can drag them around, and we can remove them as expected as well. So everything works, but we have our stuff abstracted out. Now, next, we have to talk about how can we separate this out into its own system. It's actually going to be really easy. What we're going to do is we'll right click our inventory, open in File Manager, and we'll open it up like this. And then we're going to go out to GitHub right here, and I will create a new repo. And then we'll just make our repository called inventory system, and we'll make that public because I'm cool with you guys using it. And we'll choose a license of MIT because I'm okay with you guys using my code for whatever. And if we want to add a README, we can. I don't think it's necessary, but we'll add one. And we'll hit create repo. Now this is a public repo, so we'll click on code. We will copy this right here. We're going to come in here. I'm going to go back one. I'm going to click up here, CMD, and then I'm going to type get clone. I'm going to right click and hit enter. And that's going to clone it into inventory system. And we're going to need to go back into Godot real quick because Godot is going to pick up this new inventory system folder. And we'll just move these guys into here. So we'll just grab both of them, drop them in, hit OK, and then change this from inventory to inventory system like that. And that should be okay. And then we can just delete that. We hit play. We do have a crash when we add an item, and that's because our script's item.gd. So we'll click on item.gd, copy this guy, and paste it in there like that, and that will update that. So if we refresh, it looks like we have a small bug here. So let's drag our inventory button up into our mouse area. Let's hide it, and let's try this again. For some reason, that must have gotten delinked. We'll hit add, and everything seems to be working. Our inventory is pushed over there. So let's take a look at our 2D scene. Let's hit F and take a look at where our inventory button is located. So if we show it, it's way over here. So that's a problem. So we'll need to move this back to where our mouse cursor would be. There we go. And now if we hit play, that's correct. So we'll hide this, hit Control S, and we should be good to go. Now all we have to do is we can go into our command prompt here, and we can say git add -- all. We can hit cd inventory system git add -- all, and then git commit -a -m space quote init commit. And what that's going to do is that's going to commit all of that stuff. Then we're going to git push, and that'll push all of that code right up to my inventory system. So now we have a separate module here specifically. So if people want the inventory system, they're not sitting there going, oh, I have to download the entire Godot horror game just to get access to the inventory system. I can just pull it directly. I don't need to worry about it. Now, what we can do is basically come into our Godot horror game here, and we can go into our add-ons, FPCGI. We have our inventory system, so let's just delete that and let's get rid of it real quick, because we already have it pushed up. If we go out to Find.CGI and we go out to our repos, you'll see that we already have it pushed right here in our inventory system. We click on our clone and we click on copy right here. We can come in here, cd into our add-ons / Find.CGI / and then we can git submodule, add, right click and enter, and it will automatically clone it right here like this. And then once it has that, we know we're good to go. So we can go back to our Godot horror game, and you can see we have a get modules. And this get modules is what's important. This basically tells Git what our submodules are. If I open this up in Notepad, you'll see we have a submodule. It is located here. Here's our path, and here's our URL to that submodule. So now we can basically just get status and then commit it. So we can get status, and you'll see that it says, hey, you've added some Git modules. And then we will git -- all git commit -a, and then we'll say added submodules. We'll hit escape : WQ and git push. And there we go. So now if we go out here, we go to our Find.CGI, we go to our Godot horror game. You can see here, if we go into our add-ons / Find.CGI, you'll see we have a pointer to inventory at 884E8FO. And if we click on that, it takes us to our inventory system code here, our little repo here. And that is the power of submodules. So what is the advantages here? Well, A, if projects are sharing your inventory system, they don't force you to update when you update your inventory. All of your code is segmented in this small little repo. Any bugs or anything associated with it is in this repo, and you can share this between all your projects. And the coolest part is, if you make an update to this repo, it's not going to affect anyone else unless they choose to update, which is really nice. And the other really cool part about this is if we want to clone our repo for our Godot horror game here, all we have to do is we copy our little clone right here. We go into wherever our directory is. So let's say C temp. Let's open up a command prompt here and just say git clone, paste this guy, -- recurse sub modules, and it will go and it will clone out your stuff and recurse your sub modules. So now it cloned it and it has your add-ons right here. So this is nice because all of your code is basically segmented into their own areas, and it makes things a bit more simple to use for larger projects. And this is usually for larger projects or projects where code may get segmented out for specific reasons. In my case, I did this because it's going to be easier for people to use my inventory system in their own projects if it's a submodule than if it's not. So that was just something I wanted to cover so you guys are aware exists. So at this point, I think we're pretty good. We set up a wait system. We did a bunch of bug fixes on our inventory system, and we abstracted our inventory system out into a submodule to make it more detached from our base project, which will help us later if we ever need a inventory system in the future. So that is all I have for you guys today. So if you like this video, hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I am here to make content for you guys. This video was a viewer suggested video, kind of basically a bunch of feedback from people, which prompted me to update the inventory system. So if you have any suggestions or feedback on this inventory system, please let me know in the comments below and I'll try to add it. I want to make this into a system that you guys will actually use in your game. So I'm always up for additional features or additional things that you think would be useful. So let me know in the comments below. And hey, if you have any questions or comments about this, throw them in the comments below and I'll be more than happy to chat with you, or hit me up on Discord and I will try my best to get to you. It's been a little busy this past week, so I haven't had time to really be on Discord or really make any videos or do any real work for YouTube, which has been unfortunate. But I will always try to get to you if I can. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.